In this video, I'll be going over trig equations of quadratic form. So, to review, a quadratic equation is something in this form. Okay, ax squared plus bx plus c. So the key thing to remember is the variable is getting squared. So a common, or an example of this could be something like x squared plus x minus 12 is equal to 0. So recall the way that we can solve quadratic equations. We can factor. That's the quickest and easiest way to solve a quadratic equation. We can use the quadratic formula if we can't factor. If we have two terms, something like this, when b is equal to 0, we can use the square root property. And that just means take the square root of both sides. We can also complete the square, but we're not going to address that here. So a trig equation in quadratic form, instead of the coefficients a, b, and c, we may have trig functions in those places. So something like this: sine squared of x plus sine x minus 12 is equal to 0. So notice how that's pretty similar in form to what we had over there. And we can solve these in using the same principles as an algebraic quadratic equation. So we can factor. If we can't factor, we can use the quadratic formula. And if we have two terms, we can use the square root property. So to factor the algebraic equation, we're going to say x plus 4, x minus 3, and then we set each equation equal to 0 to solve. Okay, so it's going to be a similar idea when we have a trig equation. So let's look at a few examples of this. So I'm going to solve the equation tangent squared of x is equal to -1 plus tangent of negative x. So because we have the function getting squared, that tells us that this is quadratic. So when we have a quadratic equation, we want to set this equal to 0. So I'm going to say tangent squared of x minus tangent of negative x. The argument doesn't change, it remains negative x, plus 1 is equal to 0. Now, this right here, we want to rewrite that as tangent of positive x, and tangent is an odd function. So tangent of negative x is equal to negative tangent of x, because tangent is an odd function. So when I rewrite this equation, tangent squared of x minus negative tangent of x, okay, and that's just going to be plus tangent of x, okay, and then plus 1 is equal to 0. And I'm looking back at my notes, and I failed to write a positive 2 right here. So this is going to be 2, and then 2. So tangent squared x plus 2 tangent of x plus 1. All right, now when we look at this, this is quadratic in form, and it looks like it's very similar to this quadratic equation. Okay, so when we solve this quadratic equation, what we're going to do is we're going to do x plus 1 is equal to 0, and we get x is equal to -1. And we get -1 for each branch there. So we're going to do something similar for the trig equation. This one can factor. It's going to be tangent of x, and then we want to know what multiplies to 1, that adds up to 2, and that's going to be plus 1. So we get we're going to get two equations. Tangent of x plus 1 is equal to 0. Tangent of x plus 1 is equal to 0. So these are both the same, so we really only need to solve one of them. So you end up with tangent of x is equal to -1. So we want to know what angle of tangent, or tangent of what angle is equal to -1. So if we think about this on the unit circle, tangent is negative in quadrant 2 and 4. We want angles that are in radians. So the angle in quadrant 2 is going to be 3 pi over 4. The angle in quadrant 4 is 7 pi over 4. So those are the two solutions. X is equal to 3 pi over 4 and 7 pi over 4. So for this one, let's find all solutions to the equation 2 sine squared theta minus 5 sine of theta plus 2 is equal to 0 between 0 and 360 degrees. So angles to be in degrees, and if we convert this, let me write it with theta. This is kind of like this quadratic equation. Okay, so we want to first see if we can factor this. And this is going to factor like this, so 2 theta minus 1, theta minus 2. If we multiply that out, we get to what we started with. So let's go ahead and factor the trig equation in this same format. So we're going to get 2 sine of theta minus 1, sine of theta minus 2, whoops. Okay, and then we'll just solve each of these equations. We're going to end up over here, sine of theta is equal to 1/2, and here we're going to get sine of theta is equal to 2. So the left-hand branch, sine of theta is equal to 1/2, sine is positive in quadrant 1 and 2, and those angles in degrees are going to be 30 degrees and 150 degrees. So theta here is going to be 30 degrees, 150 degrees. And then sine theta is equal to 2. Well, if we think of the unit circle, the greatest sine value is 1 at the point 0, 1. So sine is never equal to 2. If we think about the graph of sine of theta, the amplitude is 1, so it goes between 1 and -1. So the curve never actually reaches a value of 2. So what we'd say here is this branch is no solution. So what we'd say is only these two angles actually solve this equation. So for this example, we're in radians, and we have two different trig functions. We have sine and cosine. So anytime we have a trig equation, we want to write the equation with all the same trig functions. So in this case, we would want to write everything in terms of sine or in terms of cosine. Now, we should think back to what some of the trig identities that we know, and I'll write some of those here. And I guess only the Pythagorean identity is going to apply. So we could replace this sine squared of theta with sine squared 1 minus cosine squared. So we can replace the sine squared of theta with 1 minus cosine squared. So I'm going to do that. 2 times 1 minus cosine squared of theta plus square root 3 cosine theta plus 1. Okay, so doing that, I only have cosines in the equation. So if I simplify, okay, and I have like terms, the 2 and the 1, so I can write that as 3. I'm just going to erase that, write this as plus 3. Okay, so the final step I want to do before I start solving the equation is to get a leading term that's positive. So I want to turn this term positive. So if I move everything to the right side of the equal sign, I get 2 cosine squared of theta minus square root 3 cosine theta minus 3 is equal, we only need 1 0 in this equation. Okay, so looking at this equation, if we write this as an algebraic equation, now this equation I'm not going to be able to factor. So what we want to do is we want to use the quadratic formula. So if we're going to use the quadratic formula, we would say x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So in the red equation, the a value is going to be 2, b is going to be negative root 3, and c would be negative 3. So we're going to use those same values for a, b, and c in the trig equation. So I'm going to solve this, I'm going to say theta is equal to negative b, so negative of negative square root 3, so root 3, plus or minus the square root of b squared minus 4ac c all over 2 times a. So simplifying under the radical, I get square root of negative square root 3 squared, which is positive 3, plus 4 times 2 is 8. 8 times 3 is 24. So this expression right here is the square root of 27, and I can simplify that as 3 square root 3. So I get 3 plus or minus 3 square root 3 divided by 4. And in the numerator I have like terms, so I have 4, let me write this out, so theta is equal to 4, no, at this point I want to branch this off into 2 different branches, so okay, so I want to do square root 3 plus 3 root 3 over 4, and then I want to do root 3 minus 3, so negative 2 root 3 over 4. So simplifying these two, I'm going to get 4 root 3 over 4, which is just the square root of 3. And then I'm going to get theta is equal to negative root 3 over 2. And really what we've solved for is not just theta. We've solved for cosine of theta. So I should have been writing this as cosine of theta. Okay, so I have 2 little equations here. I have cosine of theta is equal to square root 3, and I have cosine of theta is equal to negative root 3 over 2. So these are the 2 branches. Cosine of theta is equal to root 3. Well, root 3 is about 1.7 something, which is greater than 1. Cosine is never greater than 1. So on this left branch, we'd say no solution, similar to the previous example. We had the no solution down here for sine of theta is equal to 2. So cosine of theta equals square root of 3, that's no solution. And then cosine of theta is equal to negative root 3 over 2. Cosine is negative in quadrants 2 and 3, and those angles in radians are going to be 5 pi over 6 and 7 pi over 6. So those are the solutions. So this is a pretty involved equation, it's quadratic in form. We needed to use this identity in order to get the equation with just cosines, and then we had to use the quadratic formula to solve. So this is about this is definitely as involved as we'll see in this class.